In the second part of this section, we will talk about how the router actually routes. So here, if any of the hosts that exist on this local area network sends the packet through the default gateway to router 1, the routing table inside R1 will be activated, which we need to understand how it actually works. As we can see here, router 1 routing table includes two major parts. The first one is what we call directly connected routes. So this network and this network and these networks are directly connected networks inside R1 routing table. So these are the directly connected routes. And there is the remote routes, which includes all other networks that are not directly connected to R1. So we need to know how R1 really learns about the remote networks, as well as how it actually learns about the directly connected networks. So unlike the host, which has one exit interface to the local area network, a router typically includes or has multiple interfaces to multiple directly connected LANs, and it also needs to learn about the remote LANs, as we will see in a minute. This is how the routing table inside the router looks like. Similar to the routing table inside the host, it includes the major columns, the destination address with the net mask, and the metric. This is the metric, and the gateway or the exit interface. This is the gateway that the router will use to send the packet to outside, and finally the exit interface that it has to use. So in details, the routing table includes the A section, or the A column, which identifies how the network was actually learned, how the router learned about this network. If it's C, this means it's directly connected, which means that the router will by default include all the directly connected networks once it starts and it activates the interfaces. So once the router starts and activates all these interfaces, it will detect automatically that these networks are directly connected to it. The B column identifies the destination network and how it's connected. So this is the destination network 192.168.10.0/24, which is this one, and it's directly connected. Or if it's a local route, which means that this local route exists on this router, which is this exit interface here. This indicates that it's a local route, 192.168.10.1/32. So we notice here the difference, /32 versus /24. So this is the actual address of the exit interface here. And this is what we call the local route for this interface. So all the local interfaces, they have such entry in the routing table of the router. This is the column C indicates the exit interface, which is Gigabit Ethernet 00, which indicates this one. So if I want to send to this destination network, I have to send it's directly connected, and I have to exit the packet to this Gigabit Ethernet 0/0. If I want to send to the destination network 192.168.11.0, any host that exists on this network will be sent to exit interface G0/1, which is Gigabit Ethernet 0/1. Okay, so to explain the routing table in details, So we have this column which indicates how the network was actually learned, and D here indicates EIGRP, which means that the routing protocol EIGRP is the one that created this entry or this row in the routing table. This pink part indicates the destination network, and then this orange part indicates the administrative distance. The administrative distance here indicates the trustworthiness or how trusted this entry is. So if it's coming from a trusted source, this number indicates how trusted this source is. This purple number indicates the metric, and this metric is calculated according to which routing protocol we use. So each routing protocol calculates the metric differently. This yellow part here indicates the gateway or the remote address that this packet should be sent to. And here, for example, it indicates 209.165.200.226, which means that router 1 will send to this IP address across this interface. So the interface here is serial 000, which indicates this interface. So I should send the packet through this serial interface to this gateway in order to send to one of these remote addresses. In that case, it's 10.1.1.0, this network. The last thing is this green part, which indicates the amount of elapsed time since this route was last updated. So if a route does not get updated for a very long time, it times out and it removes this row from the routing table. So that time indicates how fresh this routing line is. The gateway that's highlighted here, or in the routing table of the router, we commonly call it the next hop. This is the address of the device, of the network device that will receive the packet and process it further. So for example, if router 1 wants to send to a remote network, whether it's 10.0.1.1.0 or 10.1.2.0, these are remote networks, and R1 should send to this gateway through the next hop 209.165.200.226. Okay, and it sends through this next hop to one of these remote networks. So that's what the next hop actually means. So to understand this, the routing inside a router better, we have like 4 different examples here to learn which entry in the routing table that gets activated by a certain entry. So the first example here, PC1 wants to verify the connectivity to the local default gateway. So if PC1 wants to send to the default gateway and wants to check the connectivity, so in that case, it sends to the address of the interface or the default gateway, which is in that case 192.168.10.1, which is this interface, in a form of a ping. So if I want to ping this interface, PC1 will consult its own routing table, and it will figure out that this is the default gateway address. So it will exit the packet through this interface .10, which will go to routing R1. R1 will then find the destination address in the packet, which is 192.168.10.1. So it will try to map this address to one of the entries in the routing table. And as we can see, this address maps 2 lines. It maps this line. It maps this line here, 192.168.10.0/24. So if we end it with /24, we will find a match. And if we end it with this line as well, we will find a match. What the router does is that the router matches the one with the highest subnet mask here. So this is 32. This is the one that it will select. It will not select 24. So this line will be activated, in which case the router will accept this packet on this router, and it will then respond back to PC1 as a ping reply. So it will send it to the higher layers of routing R1, and it will respond back to PC1 with a ping command back. Example 2 talks about the fact that PC1 wants to send to a packet to an address 192.168.11.10. So it's on this LAN right here. So in that case, PC1 wants to send to PC2. We will check for a destination address that matches this address, and as we can see, it matches this entry here. So we match 192.168.11.10 with this entry, and it does match, in which case router R1 will exit the packet to the interface Gigabit Ethernet 01, which is this one. And this network in that case is directly connected to R1. So R1 does not need to send it through any further gateway. It sends it directly through the direct interface that it's connected to it. Example 3 here talks about the fact that PC1 wants to send a packet to an address 209.165.200.226, which is this interface of router 2. And again, router 1 wants to send this to router 2. In this case, router 1 will check all the entries, and as we can see here, it matches this this entry 209.165.200.224/30. And pay attention to this, because /30 here talks about the fact that any IP address that's beyond 224/30 will be activated by this entry here. And this AND operation, we will learn about it in the next chapter. So in that case, this network is directly connected, and router R1 will exit this through interface serial 001, which is this serial interface, and it will be sent to router 2 for further processing. The last example here, PC1 wants to send to address 10.1.1.0. This exists on this remote network, and in that case, R1 will try to send it through this interface to R2 for further processing. And this will activate this entry right here, which is 10.1.1.0/24. And this will be sent to this next hop through this gateway, and it will be sent through interface serial 000. So in that case, R2 will have to pick up this packet and will have to reroute it further to the next hop. So that concludes this chapter, and be aware of the fact that both section 3 and section 4, this section 3 talks about the anatomy of routers, and section 4 talks about configuring a Cisco router. This will be done in the lab, as they actually contain how to configure a router and how to understand the architecture of the router from inside. So that requires the fact that you have to look at routers physically. So this part will be done in the lab. So to summarize this chapter, in this chapter we talked about the network layer protocols. In section 1, we talked about the main characteristics for the network layer protocol, what is the role of the network layer protocol, and we talked about the main characteristics for IP version 4 and IP version 6, and the the shortage and depletion of IP version 4, which has led to standardizing IP version 6. In section 2, we talked about routing in two locations, how a how a host routes, and whether it uses loopback or it uses the default gateway, or it uses the routing to the local network, and how the router actually works, and how the routing table inside the router gets used and activated depending on whether we want to send to a directly connected network or we want to send to a remote network. That concludes this chapter. See you next time.